Okay, in this video, the objective is to be able to represent and solve counting problems using Venn diagrams. Okay, if you remember, here's a Venn diagram, right? And so you have event A, event B, and these are also typical overlapping or disjoint events. Anyway, let's do a few examples. You can see what we're talking about, how you would solve these using a Venn diagram with two events. If you look at this, well, let's start with the easy one first. Let's take a number cube, a normal number cube, and let's start with this one. What's the probability that it's going to, that I roll a number greater than 3 or even? Greater than 3 or even. So event A would be the one that's greater than 3. So my greater than 3 is 4, 5, and 6, right? This is going to be greater than 3, okay? And B would be or even. It's an even number. So the even numbers on a die are 2, 4, and 6. Well, we can see that 4 and 6 really belong in the middle because those are greater than 3 and even. And we want to find the probability that a number is greater than 3 or even, and so we have a few numbers missing up here. 1 is not greater than 3 or even, and then 3 is also not greater than 3. It is 3. It doesn't say greater than or equal to. So 1. Let's see if make sure we have all the numbers represented here. 1, 2, 3, 4, 5, 6. Okay. So the probability, of course, it's out of 6 that a number is greater than 3 or even would be 1, 2, 3, 4. 4 out of 6 or 2/3. Now, if I was to say, what's the probability that it's greater than 3 and even, greater than 3 and even, now I have out of 6 choices, only 2. 4 and 6 are greater than 3 and even. So that's 2 out of 6 or 1/3, right? Those are overlapping. Okay, so let's do a few more how we maybe use a problem with this Venn diagram. And again, I think the easiest way is to do some, and then you'll see the cases where you'd want to use a Venn diagram to solve these. Let's look at this spinner here. I'm going to spin this spinner, and I want the probability that I'm going to land on an even number and a multiple of 3. So all my even numbers are 2, 6, 12, and 14. That's the even numbers. That's the probability of A, that it's even in this problem here. And the multiples of 3 are 3, 6, 9, and 12. Well, we can put the 6 in the middle because that is on both of them. And we'll put the 12 in the middle because that's on both of them. And we have some numbers out here. Let's see, 2, 3, 5 is neither, so that's on the outside here. 6, 9, 11 is on the outside here. Doesn't matter where on the outside. 12 and 14. 14 was here. Okay, so there's 8 different possibilities, and so the probability that it's even or a multiple of 3, well, that's 1, 2, 3, 4, 5, 6. There's a 6 out of 8 probability, or 3/4, that a number spawned on this wheel is going to be a multiple of 3 or, you know what? I said even originally, didn't I? It's a even and a multiple of 3. Let's redo that. Even and a multiple of 3. There's only those 2. So it's a 2 out of 8 or 1/4 chance that it's a multiple of 3 and even. If I was to say the or, multiple of 3 or even, then again we have 1, 2, 3, 4, 5. That's the 6 out of 8. Okay? And 3/4. This would be the or, this would be the and. And let's do one more. Let's do what's the probability that it's prime or odd? We'll do prime or odd. So A will be the prime numbers, B will be the odd numbers, the event B. Well, the prime numbers in here are 2, 3, 5, 11. The odd numbers are 3, 5, 9, and 11. So we have a 3 and a 5 and an 11. Right? And not included is 6, 12, and 14. So out of 8 possibilities, the probability that it is prime or odd is prime 1, 2, 3, 4, 5. 5 out of 8 that is prime or odd. I think I said even somewhere. Anyway, here's the overlapping and disjoint events or using Venn diagrams to solve these kinds of problems. Thank you.